In this chapter, we are going to be working on polynomial functions and rational functions as well. Okay, so in this first section, this first problem set, looks like polynomial functions and their graphs. So let's quickly review what's a polynomial. Let's dive right in. Polynomial is just powers of x being added to each other. So you have like x to some power, I don't know, with some constant out in front, plus next one with some constant out in front, x to a different power, and so on and so forth. Just powers of x being added to each other and maybe multiplied by some constant as well. All right, that's all a polynomial is. And I'm guessing soon I'll start asking about zeros of polynomials and all that, which we'll dive into when we get there. Those are usually the important topics. Otherwise, it's just any typical function. Okay. By the way, a polynomial, this is an important thing in calculus, and probably for some of these problems in this SAT exam as well, the domain of polynomials is always all real numbers. So all values of x, if x is the input variable, all values of x works for polynomials. That makes your life easy, actually. For rational functions, that's not true, and we'll get there when, I'll talk about it when we get there. All right, so let's begin. Number one, function f is this guy, intersects the x-axis at 3, 0. What is the value of a? So this is just asking you to plug this in to the function and then solve for a, as simple as that. So x is 3, y is 0. So 0 is 3, so a times 3 cubed plus 3 squared minus 18 times 3 minus 9. Okay, and then you just gotta do the math here. So what is that? 0 is, that 3 cubed is 27a. This is plus 9 minus 9, that's 0. What's 18 times 3? That is 30 plus 18, that's 48. So actually, let's write this as 48 is 20. Did I do this right? I'm looking at my previous answer and I got something a little different. Actually, yeah, so this is not 48. It's 30 times 20, 30 plus 24, sorry. So 27a is 54. So a is equal to 2, and that's your answer. Okay, so this is just simply knowing how to use the function itself. Knowing how to work with it. Nothing special about it. In the xy plane, the graph of the function f has x-intercepts at this, this, and this. Which of the following could define f? Okay, so if it has x-intercepts at these points, for polynomials, you can write them as factors. So if there's x-intercept at x equals, at negative 7, then there's a factor of x plus 7. Okay, this one would be a factor of x plus 5, and this one would be a factor of x minus 5. Okay, imagine this is equal to 0. Okay, that's how we find x-intercepts, right? We set the y value equal to 0. So when x is negative 7 or negative 5 or 5, then that's when it's 0, so that's the x-intercept. So it should be of this form. Now let's look at the choices. Well, actually, we can combine these two. So it'll be x plus 7. This is the difference of two squares. X squared minus 25. And that looks like it's choice C, right? Okay. What is the minimum value of the function graphed on the xy plane above for x is between minus 5 and 5? So let's count 2, 3, 4, 5. So, okay, minus 5 to 5 is this. Minimum value is the smallest value of y. Value is y. The y value, or the output of the function. This is clearly the minimum here. What is this? Minus 1, minus 2, minus 3, minus 4. That's the answer right there. Very easy question. All right, next. Function f has 4 distinct zeros, which of the following could represent the graph of f in the xy plane. If there's 4 distinct zeros, then it should cross or touch the x-axis 4 times then. Okay? How many here? 1, 2, 3, so that's not enough. 1, 2, 3, 4, that seems to be enough. Let's keep that. 1, 2, that's not enough. 1, 2, 3, 4, 5. This is 5, too many times. So answer is B. Okay, last one. Graph of f shown here. Which of the following is true? F is strictly decreasing for x between -5 and 0. -5 is probably here, right? Yep, to 0. Is it strictly decreasing? No. Over here, it's neither increasing nor decreasing. It's flat. So, 1 is not true. Cross that out. And we can eliminate these two right away. All right? F of -3 is 1. 1, 2, 3. This is x equals -3. F of -3, that is 1. That seems to be true, right? So, let's keep that. All right, F is minimum at x equals 5. X equals 5 is here, but isn't this value smaller? This value of F, the Y value? So this is not true. Answer is 2 only, B. Okay, this is a short video, so I guess let's move on to the next section as well. This is also called polynomial functions and their graphs. Okay, so let's continue. Okay. If -1 and 1 are two real roots of the polynomial function this guy, and 0, 3 is the y-intercept of the graph of f, what is the value of b? Okay, so this one might require a little bit of work. They tell us these are roots, and this is a point on the graph, and specifically the y-intercept. And we're asked to find b. How in the world would we do that? Okay. So maybe let's try plugging this in. What do we get? F of 0, which we know is 3 by here. What if we plug in 0 into each one? It'll be a times 0 plus b times 0 plus c times 0 plus d. So d is equal to 3. Okay, that might help us. We found one of the variables. We need b specifically, but we found one of them. That might help us in the future. Okay, two real roots of the polynomial. That means that the points are -1, 0 and 1, 0. This was the y-intercept. These are the x-intercepts, 2 of them. Okay, so maybe let's plug those in as well. F of -1 would be, we found d by the way, so we can just use that. It'll be -1 cubed, which is -1, so minus a plus b minus c plus d is 3, right? And f of 1 is, we plug this in, f of 1 is, plugging x as 1 to here, it'll be a plus b plus c plus 3, and we know those two are equal to 0 because they tell us they're roots or x-intercepts. Okay? Now can we find b? What if we add these two equations together? Okay, so minus a plus a is 0, b plus b is 2b, minus c plus c is 0, plus 3, that's plus 6, and then on the other side, 0 plus 0, 0. So b looks like it is 6 over 2 with a negative sign, so minus 3. That's the answer. Okay, so this was not hard by all means, but you had to be able to problem solve this. They give you this point, and they actually give you 2 other points. So from here, you can just imagine they give you a lot of information right there, and there's 4 unknowns, so you could probably find the last unknown. Okay, so that's just simple problem solving skills that you need to be able to develop. They need to develop and have. Okay, you got to take the information that they gave you and somehow use it. Sometimes there's extra information that doesn't help, but you got to be able to figure that out. Okay. What is the remainder of the polynomial this guy divided by x plus 1? Okay, so for this one, you could do the long division, but that takes time, and I'm lazy. I don't want to do that. There's this weird theorem, it's like the remainder theorem or something like that, that you could use. What does it say? Well, if we divide exactly p of x divided by x plus 1, you'll have some quotient, and you'll have some remainder as well. Okay? So what if I multiply everywhere by x plus 1? So p of x plus equals q of x times x plus 1 plus r of x. Okay? What if x is -1? So p of -1 is q of -1 times 0 plus r of negative 1. This would go away, right? So the remainder is p of negative 1. What is p of negative 1? That is 81 with a negative sign plus 121 minus 36. And what is that? This is what? That's 40 minus 36, that's 6. Did I do this right? 40 minus 36 is for sure not 6, it's 4. I'm like looking at my answer key that I solved out before. Okay, so this is the quick way to do it, using that remainder theorem, which tells us, so this is how I understand it. If you divide a polynomial by something, you'll have some quotient and some remainder. This is exactly what's happening. And then you just multiply both sides by x plus 1, and you see that if x is negative 1, this term would go away over here. Okay? And then what's remaining is your remainder. Okay. If x minus 2 is a factor of this polynomial, which the following must be true? So there's another theorem or rule or something. I really don't remember these names, but you know that if this is a factor, that means when x equals 2, p of x would be 0. It's a factor, because p of x is x minus 2 times something else. Okay? That's what it means by when it's a factor. X minus 2 is being multiplied to some other things. Okay, so when x equals 2, p of x is 0, or p of 2 is 0, I should say. We might need to use that here. Okay? So, it's factor, which following must be true. So what if I just try plugging in 2 into here? So p of 2 is a times 8 minus 4 plus b times 4 minus 5, right? And this is 4a minus b, okay? And we know p of 2 is 0, as I said, and this is choice D. Okay? So the key concept here was, if this is a factor, okay, let me even write it out. So that means p of x is x minus 2 times something else. We don't know what that something else is, and we don't really care, because now that we wrote it like this, if x is 2, p is 0, clearly, because it's 0 times who cares? It's 0. So we use that fact to help us answer this question. Okay. Function f is defined by a polynomial. Some values of x and f of x are shown, which is following must be a factor of f of x. So, as we just saw in the earlier problem, at this value of x, our function is 0. So that means x minus negative 3 is a factor, which is x plus 3. Answer is B. Okay. For what real value of x is the equation above true? So how would we do this? Maybe we can factor. So when it's something like this, a polynomial equal to 0, you should always try to see if you can factor first, because usually factoring is the easiest way. So can I factor out x squared? This is the GCF in the first two terms, so it'll be x minus 8. And then the GCF in the next two terms is, it'll be plus 3. Okay, these are common factors now, so it'll be x minus 8 times x squared plus 3. Okay, so this is equal to 0. So I just only touched the left-hand side. Okay, so what values of x makes this true? X is equal to 8, that's the answer. There's no real solution. So this is the only answer, x equals 8. Okay. Last one, if x is greater than 0, what is the solution to this equation? Okay, so again, let's try to move everything to one side. So it'll be x to the fourth minus 8x squared minus 9 equals 0. Can we factor this? It'll be x squared minus 9, x squared plus 1. Okay? Now our solutions, well, this guy over here, difference of two squares, we can factor. X plus 3, x minus 3. This guy we can't factor. So what are our solutions? Our solution is x is minus 3 and x is 3. But to tell us that x is greater than 0, so our answer is 3. And remember on the SAT, at least back then, I'm not sure about now, you can't have a negative free response question. So it has to be positive. Okay. All right, that's it for this video. As you can see, the key ideas, at least on this page, were that remainder theorem that you might have to use every now and then to make your life easy. And when something's a factor of a polynomial, that you can easily get one of the zeros. All right. Hopefully this was helpful and good practice. Please like and subscribe if you found this helpful in any way. And please be on the lookout for the next video as well.